Hello everyone, welcome to 𝐂𝐤𝐬𝐞. My name is Venkatrao. I am discussing about compiler design subject. So in this course, we are dealing with compiler design subject, almost all the topics in 10 lectures. So this is like a short course on a compiler design. Even though it is a short course, we are going to discuss about almost all the topics and almost all varieties of the questions, especially in gate point of view. So this is what the specialty of this course. Hello students, hello everyone, how are you all? Welcome to 𝐂𝐤𝐬𝐞. Right. So our course is all about learning about compiler design from basics to advanced gate level topics. Right. So what is this compiler design? How it is useful, especially this course is mainly going on gate point of view. So our topics, see, generally in compiler design we have different approaches. Compiler design can be discussed in a programming point of view. Yeah, it's like a crash course. So compiler design generally will be like a programming point of view, like practical approach. That is one thing. Second one is gate approach. This is completely theoretical approach. So in this course, our aim is we are going to discuss about gate approach, especially in theoretical concepts. And we are not discussing anything. If it is a practical approach, then we have to touch the tools of compilers like Lex tool, Yak tool. These are the some of the tools are there. But here in this course, this is a gate orientation. So I am not dealing much on tools here. So this is about the basic thing we are going to discuss in this 10 lectures of compiler design. So notes also will be provided for you. Notes, whatever I am writing here, all these PPTs in the form of PDF, you will get it. So notes will not be an issue. So understanding the concept is very important in compiler design subject. Okay guys. So let us start. First, what is the syllabus required for GATE exam from compiler design subject? Let us focus on there. So these are the topics we are going to discuss here from compiler design subject. Okay. For gate point of view, what is the weightage of, I'll come to this individual weightage also. I'll come to this. Before going to that, so what is the weightage of this subject, especially for gate exam? So already gate notification come, application also there. I think many students are applying. So for gate, in that this subject compiler design, how it will be helpful for you in the gate exam. The subject generally, the weightage of the subject will be 5 to 7 marks. Okay, mostly I think 5 to 6 marks, you can say 5 to 6 marks. The weightage of the subject 5 to 6 marks generally will get in the gate exam from this. It may varies from year to year. Sometimes we may get 5 marks, sometimes we may get 7 marks. That varies, but normal average weightage will be 5 to 6 marks we'll get from this subject. So compared to some other subjects, the weightage is a little bit less. But the thing is, it is a scoring subject. Compiler design is mainly scoring subject. That means assume 6 marks are given, we can score all the 6 marks without any difficulty. We don't have any difficulty here. All the questions are static in nature. Static questions means most of the questions are repeated questions. So if I want to say more, so if you have thorough knowledge on concepts of previous questions, so most of the coming questions also almost like not exactly same, almost. So in the exam, in the classes also, I am going to discuss about all the questions which are asked in the previous exams. So there is a high probability of repeating similar questions. So complexity is not there in the subject is very easy, solving questions also very easy, scoring we can get good score from this subject, right? Many of the students generally think compiler design is a difficult. Compiler design is very easy. It is not at all a difficult subject. we can easily understand, we can easily score, right? Mainly thing is approach is the main thing. Generally you study in a BTech point of view, but here you have to study this subject in gate orientation. Gate orientation is completely different. Way of studying is completely different compared to what you are studying, what you are learning in our BTech classes, right? So these are the topics we are going to deal here in the subject compiler design. In this total course, we are going to deal these topics which are there for our gate examination point of view. The name of the first topic here is lexical analysis. Lexical analysis. And the second topic is parsing. Parsing. Third one, syntax directed translation. All these are the topics as it is taken from a GATE syllabus. These are the direct concepts as per the GATE syllabus. Somewhere parsing will be used as syntax analysis also. But as per the GATE brochure, I have taken this list of the topics as it is without changing any names of this. Because each of this having different names. But these names are as per the GATE syllabus. Right. Next one, intermediate code generation. Next one, code optimization. Last one, runtime environment. Okay. Here in this, I told you generally we'll get 6 marks from this. Out of all these 6 marks, 50% of the topics or 50% of the questions generally get from the second topic, parsing. Parsing is very, very important. Mostly 50% of the questions out of this all in this total topics, 50% weightage will be there for the second topic. Parsing is very, very important. Actually, the whole compiler design is all about parsing. If you know parsing, nothing is there in compiler design because every of these connected with parsing, every concept of this connected with parsing. Right. So 50% here. Generally, we can expect 20% from this, 10% from this, remaining 20% from these areas. So these are the weightages of all these topics. So here in classes also, so lexical analysis just 10% weightage. So in today's class, in our today's discussion, we are spending a lot of time on the lexical analysis. That is what our main aim. The name of the topic also lexical analysis. So we are going to complete this. From tomorrow onwards, almost 4 to 5 classes we are spending on parsing. So parsing is a major important concept for us. Okay, right. So these are the topics we are going to discuss. Weightage of each topic, weightage of the overall subject, compiler design, 5 to 6 marks. Okay. So students, then we'll move to some other thing. If you are studying compiler design first time, what are the books generally you need to refer? Many students are having doubt. So there are so many books available in the market for GATE point of view. See, I recommend don't read any book at this point of time because we have very 5 months time. So it is very difficult to complete all the books. It's difficult to read all the total book because one more thing is the syllabus of the GATE will not be covered by any one standard book completely. That's why you need to go through different books. So better thing is listen classes, solve GATE questions, and in the topics if you have any doubt, then that topic you refer from the book. Reference books use only for referring the topics, not to read from first page to last page, because each book having so many unnecessary concepts which are not required for our GATE. It may be required for your BTech curriculum, which is not required for GATE. We have a code generation. See here, there is a topic called as code generation. The code generation topic will not be there here. Code generation is not required for GATE examination. That also will be included whenever you are reading book. That is not required. From the lexical analysis, there are so many unnecessary concepts like regular expressions, finite automata, conversions. Those anyhow we will study in theory of computation. That's why all these things also not required here. Right. So what are the general books? First one is anyhow the standard book, Ullman, best book throughout the world. Ullman is the top book, best book, which is referred throughout the world in all standard universities, but it is very lengthy. Use this to read only some of the concepts. I suggest you only Ullman if you have any just for solving the questions. That's all. So mainly understand the concepts from classes, solve questions. Other than Ullman, I don't suggest any other book. This is the only standard book. Okay, right. And one more thing, many students will ask, what are the prerequisites required to understand the subject? What are the other subjects knowledge required to understand the subject? So one subject is compulsory to understand the subject. The knowledge of one subject is compulsory. That is theory of computation. So majority of the topics here, lexical analysis, finite automata concept, regular expression concept, parsing, grammar concept, ambiguous. Anyhow, I'll discuss some of the basics. So these are the some of the topics from theory of computation. Any normal basic knowledge of data structure and algorithms. That's all. Programming knowledge is not required. Practical view of compiler we are not discussing here. Here our approach is going towards gate. So how to solve the questions of gate? To solve this, the theoretical concepts of compiler we are learning here. This is what the overview of this one. Okay, right. So is it clear, students, till now? Okay then. So let us start the subject compiler design first from the basics onwards. What is this compiler? We'll see the definition, how a compiler looks like. Then we will go and see lexical analysis and each and every phase of this. So there are some definitions for compiler. So let us see the standard. What are the definitions here? Compiler is a software. Compiler is a software which converts program written in high level language to low level language. Low level language called as object, target, machine languages. High level languages are called as source languages. So compiler generally a software, or it also called as a translator. Compiler can also be called as translator, translating high level language to low level languages. So generally compiler is a software. So what is this software is doing? The software is translating high level language into low level language. We can see some of the practical compilers. Take C compiler. What a C compiler is doing? Whenever you write any C program, the moment you compile, compilers will do two things mainly. One is translation. There are two things, main things done by the task done by the compiler. Translation. Second one is error detection. Translation and error detection. So I'll take the C compiler here. So what C compiler will do is C compiler translates C language to assembly language. C compiler translates C language to assembly language. So Java compiler, anything. So this is like this. These are called as C, C++, C, C++, Java. All these languages are called as high level languages. Translating these high level languages into low level language like assembly language, byte codes, low level languages. So translating like high level language into low level language done by the software. Name of that software is called as compiler. This is one task. One more task is, before doing this translation, compiler identifies errors present in the program. errors present in the program name as compile time errors, compilation errors. Generally, the errors of compiler detected errors are known as lexical errors, syntax errors, semantic errors. The compiler detected errors are classified into three categories: lexical errors, syntax errors, semantic errors. So if you don't identify an error directly, if you translate, unnecessary time waste to the machine. That's why compiler first it detects any errors present in the program or not. If errors present in the program, then compiler will try to report those errors to the programmer. If those errors are corrected, then translation will be done. That's why mainly tasks done by compilers are error detection and translation from high level to low level. Right. Okay, this is the task done by the compiler. If you see any practical compiler's code, generally how many lines of code will be there? Like normal C compiler, Java compiler, any of these compilers code, if you observe, compiler is not a small program, 100 or 200 lines program. It is lakhs, 10 lakhs, 15 lakhs, 20 lakhs lines of code will be there. So designing compiler at a time is very difficult approach. That's why whatever the software I am saying, which is doing error detection and translation, this total task will be done by multiple different programs. The total structure of the compiler, if you observe, it looks like this. It seems to be task is same thing, translation process, but this translation process will not be carried out by a single program. This translation process is carried out by multiple programs. Now this is our whole compiler. It is software translating high level language to assembly language, same software, but this translation process, error detection process, carried out by multiple sub programs. Each program is called as one phase of the compiler. One phase of the compiler. So all these are called as lexical analysis phase, syntax analysis phase, semantic analysis phase. Like this, each one is called as one phase of the compiler. Each of this will do one particular task. So in compiler design, what we are learning is, so design of a software, big compiler software is nothing but designing of all these programs separately and club them, merge them. Then our compiler will be ready. So in compiler design, what we are going to learn here is how to develop each of this program. How to, in compiler design means designing of each of this program separately and merge them. All the tasks performed by compiler will be performed by each of these programs individually. Okay. So let me write first program, name of the first program, lexical analyzer or lexical analysis phase. What is the task done by this program, lexical analysis phase? Lexical analysis is a program. Lexical analysis is a program, first program of the compiler, which is interacting with high level language. So what this lexical analyzer will do, it will translate high level language into tokens. So translation will not be carried out at a time. Compilers will not translate all your high level language into assembly language at a time. That is very difficult process. That's why the translation will be done like this. First high level language will be translated into tokens. Then tokens will be translated into parse tree. The translation having particular purpose. We'll see what is that purpose while developing these phases, these programs. Then these parse trees will be translated into annotated parse trees. Then intermediate code will translate this into 3 address code. Then optimizer will optimize this. optimized 3 address code, then assembly language. Like this, the translation will be carried out in multiple phases. Each phase is one subprogram of the compiler. So designing of each subprogram is our actual task of the compiler here. Okay then. So today, in today's discussion, we are going to learn how to design the first phase. What is lexical analysis, what it is doing, how to design lexical analyzer, what are the techniques, what are the different things available in this. So, and then in every class, designing, how to design this, what are the concepts we are using to design this, all these things we are learning here. So our discussion will be on lexical analysis in today's class. So let us go to the lexical analysis phase of the compiler. Right. So lexical analysis is the first program in the compiler which is interacting with our program. I assume we have written some program. We have written some program like something, any C program or something, main. Some program is written. First, this program is taken by the lexical analyzer. What is the main task of the lexical analyzer? Lexical analyzer translates your program into tokens. Every of this program having input outputs. All these are programs, no? So having every program is having input or output. Input to the lexical analyzer is C program. Assume a C compiler I am designing. Input to the lexical analyzer, C program. What is the output of the lexical analyzer? So output of the lexical analyzer is tokens. Tokens. So we are going to learn what are tokens now. Tokens. So this is the major task done by the lexical analyzer. Reading the program, breaking them into tokens as output, taking program as input, producing tokens as output. This is the main task. And not only this, there are so many other tasks performed by the lexical analyzer. So the task done by the lexical analyzer is not only this much. We have other thing, that is lexical analyzer produces tokens. The role of the lexical analyzer is producing tokens, specification of tokens. Then let me write here separately. These are the things. Producing tokens. Next one, detecting lexical errors. So first one is functionality of lexical analyzer, producing tokens as output, detecting lexical errors, and removing comment and white space. Removing comment lines and white space characters present in the program. Fourth one is constructing symbol table. So lexical analyzer is not just doing one task. Lexical analyzer doing so many tasks. Producing tokens as output, lexical error detection. We have seen previously compiler will detect some of the errors present in the program. In that we have some errors called as lexical errors. What are the lexical errors? Errors identified by lexical analyzer. So this type of errors also detected here. And then comments, removing comments and white space characters present in the program. So if you have this, also removed by this. So let us see one by one all these things. Construction of symbol table. Symbol table construction is also done by the lexical analyzer here. So first we'll focus on each of this. First our concentration will be on, let us move to the tokens. What are the tokens here? So this is the token. Token is a sequence of characters that can be treated as single logical entity. So tokens are nothing but, so I am saying tokens is the main concept here. The main concept of lexical analysis is nothing but tokens, detection of tokens. What is token? Token is sequence of characters that can be treated as single logical entity. See, in any program, if you have any program, in any program typically tokens are nothing but identifiers, keywords, operators, special symbols, constants. These are called as tokens. See, in any program, whenever we are learning about any program, C program, Java program, and whenever we are learning any program, first what we will learn? Tokens of that language. What are the tokens of C language? Sorry. So whenever we are learning about any language, first we will learn about tokens. Tokens. So generally tokens are nothing but so these are called as normal tokens. First keywords. Then identifiers. Next one, constants. Next one, operators. Next one, special symbols. So all these are called as general tokens of the language. All these 5 things so all these 5 things are called as generally tokens. So what is the lexical analyzer is doing? So these are called as normally tokens. Keywords are some of the tokens. Identifiers, some type of tokens. Constants are some type of tokens. Operators are some type of tokens. Special symbols are some type of tokens. So in any programming language, these 5 things are normally called as tokens here. So what is lexical analyzer? So lexical analyzer is reading program as input, this whole program reading as input and producing tokens as output. This is the task done by the lexical analyzer. So how it will produce? Let us see now. Assume we have one statement. This is the declaration statement we have. This is a normal programming statement, declaration statement. If this I have given as input to the lexical analyzer and tokens will be produced. So for this input, how many tokens will be produced? How the tokens will be produced? What are the tokens produced by normal lexical analyzer program? The tokens are nothing but break the program into 5 things. Whatever may be your program, we have to break this program into our previous 5 things called as keywords. Read group of characters as input. The task of lexical analyzer, read sequence of characters as input. That sequence of characters should comes under one of this category. Either it should be a keyword, it should be identifier, it should be a constant, it should be operator, it should be a special symbol. So breaking the program into like this, any one of this. So assume we have this one. Our program is int semicolon like this. Then if I give this one to the lexical analyzer, first it will read this group of characters. It will break this into keyword. This is identifier. This is a special symbol. This is identifier. This is a special symbol like this. So this is one token known as keyword. This is a token known as identifier. This is a token known as special symbol. This is identifier and this is special symbol. So if this sequence of character all together as input, producing outputs like this. So these are called as tokens. So what the lexical analyzer will do, it will group the characters. It will read character, every individual character as input. It will group some characters as one meaningful entity. That meaningful entity can be a keyword, can be identifier, can be a special symbol, sometimes can be operator. Okay. These are normally these classes will be there for 10 days. These are 10 classes are scheduled here on this. So on these 10 days we are discussing about almost all concepts. Okay, right. So these are the tokens. So number of tokens, how many tokens will be produced? All this group of characters, one token, because it is a meaningful entity, keyword. Every group of characters should come under those 5 things. It should be a keyword. So this group of characters forms keyword, comes to the meaning of keyword. This is identifier. This is special symbol. This is identifier. This is special symbol. So total 5 number of tokens will be produced by lexical analyzer. 3 p.m. is a fixed time every day. Every day 3 p.m. we have a class, compiler class, that is fixed time it is. Okay, right. So now I am giving one program statement, expression. This is the expression. Assume this is my input to the lexical analyzer. How many tokens will be produced for this input? If I give input like this, how many tokens will be produced by the lexical analyzer? How many tokens will be produced by the lexical analyzer if my input is like this? Whenever we have any program statement this way, how many tokens will be produced. Read every character. Any sequence of characters should be either keyword, identifier, operator, special symbol, constant. Should comes under any one of this. So if I give this as an input to the lexical analyzer, first it will read this. This A itself comes under the meaning of identifier. Identifier. This is operator. This is identifier. This is operator. This is identifier. And this is a special symbol. So total number of tokens comes for this is 6. So number of tokens. The total thing is input here. This is input. The output for this coming out of the lexical analyzer will be 6 tokens. 6 tokens. So this is what the meaning of lexical analyzer, what I am saying previously. So it takes program as input and produces tokens as output. Okay. Assume my input is this one to the lexical analyzer. So there is a space here. Comment and spaces will be removed. So this is my input to the lexical analyzer. So I am giving this as the input to the lexical analyzer. So how many tokens will be produced by the lexical analyzer for this? How many tokens? How many tokens produced by lexical analyzer for this input? If my input is like this, then how many tokens are produced by lexical analyzer for this? Just try to identify how many tokens here. Every group of characters should comes under one of the meaningful entity. That should be a keyword, identifier, operator, constant, special symbol. Very good. So this is, all this comes under one token, identifier, 2, 3 special symbol, 4 keyword, 5, 6, 7, 8, 9, 10. So total, if this is the input to the lexical analyzer, the output will be produced as 10 tokens. Very good, very good. Like this, the token generation. While generating tokens, we have so many complexities here. Token generation is one of the very important concept of lexical analysis. So let us see, we'll see some more different varieties of programs. Here, how the tokens will be produced by the lexical analyzer. If I give same statements in this way, how many tokens generally lexical analyzer will produce? We'll concentrate something on operators. While producing tokens on operators is somewhat more different way. So, okay, first we'll go for the constant. This is one of the statement we have. So, if for the statement, how many tokens will be produced? If we have a statement like this, how many number of tokens produced by lexical analyzer for this? Whenever you have a normal statement, program statement in this way, how the tokens will be produced? So identification of from the statement, generation of number of tokens. What are the types of tokens available in this? Here also we have, just first we have identifier. We have a token called as identifier. and this is a constant operator. This is a constant. This is a special symbol. See here, no need to worry about this. No need to worry about this. The token is like this. Start from the, whenever you say keyword, start first letter to end of the keyword, total meaningful. So here identifier will be ended here. So this is one token, operator. This is one token, constant. Digit started here, end of the digit till this, one token, constant, special symbol. So total 4 tokens. The number of tokens generated will be 4 tokens. Assume our statement is okay. So these are the 4th and 5th. Can you find out how many tokens for the 4th, how many tokens for the 5th one? Number of tokens present in the 4th statement and number of tokens present in the 5th statement. We have so many challenges. Whenever lexical analyzer is generating tokens, there are some challenges to the lexical analyzer. Now let us try to see what are these challenges. It has to generate properly tokens. Just producing is not sufficient. It has to produce the tokens in a proper way. So how many tokens for the 4th statement? Whenever we have like this, identifier, operator, identifier, special symbol. Number of tokens we can get for this is 4 tokens. How many tokens we'll get for the 5th one? The number of tokens we'll get for the 5th statement is, see here, whenever we are discussing about token operator, operators are like this. We have these arithmetic operators here, and this is also operator, increment decrement operators. So for plus, whenever we have plus, this is also one token, plus plus also one token. How to differentiate this? Whenever we are getting plus operator, don't produce token. See the next symbol called as look ahead symbol. We have to see the next symbol. These symbols together also making a meaningful operator. So just whenever you are getting plus, don't produce the token. See the next symbol also. If both are plus, then this together also makes a meaningful operator. Then give priority for the maximum length operator. So this both plus plus also will be produced as one token. Plus is also operator, plus plus is also operator, for which we have to don't produce 2 tokens in this. Lexical analyzer will produce only 1 token because the maximum length operator whatever is there, for that priority will be given. In the same way, minus, minus, minus. If we have a minus, don't produce a token, see the next symbol. Together forming a meaningful operator, then produce a token. Like this, based on the next symbols, the decision, token decision, when to produce token decision taken by the lexical analyzer by looking at the next symbol, that is called as look ahead symbol. So next symbol, by using the next symbol, it is forming a meaningful, is it forming a meaningful thing, meaningful operator. Then we have to give 1 token only. For that, even for the length of the operator is high, no problem. For this maximum length one, will produce as 1 token here. So based on this, so here whenever we are generating tokens, 1 token here, 1 token here, 1 token here. So total number of tokens produced for this will be 3 tokens. 3 tokens. So plus plus, plus is operator. Whenever we see the next symbol, plus and B together is not forming meaningful one. That's why here plus only the token. Here plus, see the next symbol, plus plus together making a meaningful operator. So this also comes under one token. So this is one token, this is also one token. Based on this, total 3 tokens will be produced by lexical analyzer. So these, based on this type of questions in the token generation, these type of questions we can expect in the GATE exam. Okay, right. Assume I have a any program statement like this. How many tokens will be produced by lexical analyzer for this? How many tokens? How many tokens? How many tokens produced by lexical analyzer for this? Based on the plus operator, plus can be sometime arithmetic operator, sometime increment operator. Based on this, identify how many tokens produced. Please take your own time, 2 or 3 minutes. Based on that, find out how many tokens will be produced. Very good. Many of you are giving correct answers. Nice. So here, this is identifier. Whenever we have plus, don't stop here. See the next symbol. If plus plus is there, plus plus is the operator, and next also plus is there. 3 plus operator is not available. Assume the C compiler. We don't have 3 plus continuously. There is no operator. We have plus plus plus. So together one token here. And next for this, we'll see here. See the next symbol, plus plus not forming. So come here till this part, one token. Identifier only this. Identifier also same. If letter is there, that letter followed by so many letters. See the next symbol, until letters are completed, one token. So here letter is ended here, one token. Next plus. Here one token. Next C, one token. Next plus is there. This plus, see the next symbol, plus plus is there, one token. Plus is there, see the next symbol, plus plus, one token. We have only plus. So the total number of tokens count if you want. Total 10 tokens will be produced by lexical analyzer here. Is it clear about this one? So like this, whenever we have operators of this kind, the meaningful operator, in a meaningful, if we have multiple operator with the same symbol, plus plus plus, the maximum length priority will be given. Whichever is the maximum length comes under a meaningful operator. For that, only one token will be produced. Right. So in this way, these are the different type of complicated tokens lexical analyzer will generate. Seventh one, eighth one, how many tokens produced by lexical analyzer for 7th and 8th? Try to identify how many tokens lexical analyzer will find for the 7th as well as for the 8th. So here same thing, this is a less than a less than b less than or equal to b. In operators list, we have a less than is operator, less than or equal, we have this operator as well as, for this also only one token. There is only one token for this as well. That's why, so number of tokens, this is one token, 2, 3, 4, right? Same way, the lexical analyzer will generate like this. One token for this. Whenever operator is there, see the next symbol. Including next symbol also, one meaningful operator is forming. Less than or equal also one operator only. So one token. For this, one token. For this, one token. So total number of tokens produced will be 4 here. Here also 4. So number of tokens, 4 tokens. For this also 4 tokens. So whenever we have tokens related to this, this is the way of generation, right? If you have a statement like this, this is the statement, how many tokens generated by lexical analyzer for this. How many tokens generated by the lexical analyzer for this? If the statement is like this. So like this, whenever lexical analyzer is reading something, produce sequence of tokens, reading some program as input, producing sequence of tokens as output. This is the major task of the lexical analyzer, and this process is called as tokenization. So like this, whenever we are reading any program, breaking up the program into like these tokens is the main concept of the lexical analysis program. Right. So here token list is like this. First, this is keyword, 1 token, 2, 3, 4, semicolon, 6, 8. One token, 13. Total number of tokens produced is 13 tokens. Total 13 tokens produced by the lexical analyzer. Total number of tokens produced will be 13. This is the way. So for this only one token, for this only one token. Like this, we should not go in a wrong way for this. Assume we have some other statement. Okay, for this I'm changing small one. So this is the way. Comment started here, comment ended here, comment started here, comment ended here. If it is there in this way, how many tokens produced by the lexical analyzer for this code? The code is like this. What is the functionality here? Lexical analyzer generates the tokens. In the token list, comment will not be included, white space is also not included. Whenever we have comments will be removed automatically from the lexical analyzer. Wherever it is having comments are generally deleted by lexical analyzer. Comments will not be counted. Any answers for this? So what you have to do here is, Whenever we are generating for this, you should remove from our list of tokens. For comment, how it is removed? No token produced for comment. No token for comment. Whenever lexical analyzer doing like this, all the comments removed. Comments are reading here. Comments also will be read, but no tokens will be produced. That is the only thing. Right. Very good. Many of you are saying some answers here. Nice. So whenever we have the program in this way, this comment for this no token, for this no token. Then if you count one, total number of tokens 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Total number of tokens produced is 19 here. 19 number of tokens. Okay. So whenever comments are there, these are the tasks. Producing tokens as input. In this process, if you are getting comments, comments will be removed. Comments are eliminated by the lexical analyzer. Okay. So this is the functionality of the first phase of the compiler called as lexical analyzer. So if we have a question like this, which of the following is not a token in the C language? So which one will be the answer? Just type in the chat box. Which of the following is not a token in the C language? There are some things are called as tokens. Some things will be removed and will not be comes under the token list, which are nothing but comment is one thing, other one is white space. White space. So white space and comments are removed. That means white space and comment will never comes under our token list. That's why a semicolon is a token, comes under special symbol. Identifier is a token and keyword is a token. So white space, no token will be written for this. No token. This is not a token or no token. No token produced. This is not in our token list. I think now we are getting the meaning of the token like this. So this is what the meaning of the first program called as lexical analyzer. So the lexical analyzer takes high level language programs as input, produces tokens as input. Tokens as input. So in order to design this, generally the concepts of theory of computation used are finite automata concept is used. If we have an idea of theory of computation for our token rules, finite automata, regular expressions. Regular expressions, finite automata and regular expressions. By using these concepts of theory of computation, the theoretical development of lexical analyzer will be designed, and there is a tool called as Lex tool. If we give all these specifications of finite automata and regular expression, the program, equivalent lexical analyzer program will be generated by Lex. So like this, the first program, lexical analyzer, is working. So lexical analyzer main task is producing tokens for the reading input source program. So there are so many other things will not be done by the lexical analyzer, like detecting. It can detect only lexical type of errors. Remaining syntax semantics will not be detected. So the tokens will be taken by syntax analysis to perform syntax check, grammatical check of the program. So how to design this, that we will see in the lexical syntax analysis development designing. Syntax analysis also called as parser. I told you 50% of the questions Generally we'll get from the second one. Okay, the second chapter, syntax analyzer, we will start from tomorrow's session. So that's all about the lexical analyzer for today. If you have any doubts from your side, you can ask me. Generally finite automata will remember something, some small amount of thing, not large amount of thing. That is what I'm saying. That is theory of computation concept. So finite automata, generally that will be used. So how much it remember means finite nature it will remember. Okay, right. So okay students, that's all about lexical analyzer. We have seen some of the questions of lexical analyzer, how tokens will be generated. Generation of tokens is the main concept required for GATE examination point of view from lexical analyzer. So we have seen what is token, how tokens will be produced in the lexical analyzer. So that is the main task of the lexical analyzer. In the coming classes, we'll see syntax analysis, the development of syntax analysis, what are the theoretical concepts, how syntax analysis or parser will be designed. Thank you. Thank you all. See you in the next class. Bye bye. Every day class will be at the same time 3 p.m. Every day class is at 3 p.m. Okay. Thank you.